Hello, I welcome you all in this presentation related with the subject principles of industrial engineering, and we are talking about the plant layouts. In the plant layouts we have seen that there are different types of the plant layouts like the process layout, product layout, fixed layout, cellular layout and combination layout. We have talked little bit about the way by which the process layout can be designed, and we will be looking into the further details related with the designing of the process layout. Thereafter, we will see that how a product layout can be designed. We know that in the process layout the facilities are arranged or clustered or grouped according to their functions, and in this case we do not consider which type of the product will be processed through the facilities, and that is why the movement of the material through the facilities with the change of the designs, with the change of product keeps on changing. So, because of the changing movements of the material through the different facilities, different resources, different work centers, there is no fixed path for the flow of the machines, and therefore, it becomes important to see really what can be done as far as the arrangement of the machines and facilities is concerned, so that the extent of movement across the centers can be reduced, which may be in form of movement of the material or movement of the manpower, etc. So, what we do basically, we try to understand and estimate the kind of interactions which will be there across the facilities, and that those interactions are quantified in terms of the number of the movements desired and also the kind of the distances which are to be travelled. Once we get the idea about that, it becomes easy to come out with the kind of the designs that can be proposed and developed for the process layout. In general, if we see the general approach in the process layout design is that we have to see that how the machines will be arranged, so that the movement, extent of the movement or the material handling which is to be carried out is reduced. And this will be based on the kind of interactions or the extent of movements which exist along with the distances to be travelled during the production process. And we will be locating these work centers and facilities in such a way that the distances to be travelled and the movement and the material handling can be reduced. And for this purpose we follow certain steps, as I have already talked about the what are the facilities we want to establish, what are the drawing details along with the area required to accommodate these facilities, the kind of interactions, which means the kind of flow which exists between the various facilities and the centers during the production process, and analysis of this information to see really how the things can be arranged, so that the distances to be travelled and the cost coming on account of the material handling is reduced. So, whatever after the analysis layout is proposed, that is evaluated to see its effectiveness, and if desired it is modified. And at this stage only we will keep in mind if there is any specific orientation requirement or a space is required or a special access areas are to be given. We have seen that analysis of the information about the kind of flow which exist across the centers. There are three approaches which are used in the process layout design. One was the proximity analysis, about which we have already talked. This is based on the kind of the affinity or the closeness which is desired between the two work centers to next to so that they can be placed close to each other or they can be placed apart from each other. So, it is a like qualitative assessment of putting the facilities close to each other. Then there was a flow matrix preparation. Flow matrix preparation, a flow matrix gives us the idea about the extent of movement which exist in terms of the numbers, like frequency of movement between the two stations A and B is 10 or 90. So, that will be indicating the extent of movement which exists, and if the movement between the two centers is too high, irrespective of the distance, efforts are made to put them close to each other. So, in this approach we do not consider the distance to be travelled. In this approach primarily the frequency of the movement is considered for seeing the possibility if they can be brought together. Next is the kind of the flow cost approach, which considers like the what kind of the cost that will be occurring on account of the handling or the movement, handling of the material or movement of the operator. So, for this what we consider, basically we consider the kind of load which is basically in terms of the number of the movements required, and then kind of the distance to be travelled. So, the second parameter here is the distance to be travelled, it is less or more. And then third aspect here is the cost per unit distance, cost per unit distance. So, these three things are considered. So, what we will be doing, the load into the distance into the cost, these three things will be multiplied for optimize to see what will be the kind of the cost that will be occurring if the facilities are arranged in a particular fashion. So, here I will be taking up one particular example. According to this example, like say the layout of the facility is like this, wherein there are 4 work centers like A, B, C and D, like A, B, C and D. This is the current layout, and the extent of movement which exists between them obtained from the flow matrix analysis is coming out like this. So, that is what we can make in tabular form, like A to B movement between the movement between the A and B work center is of the, that we can write like A load in terms of the frequency which is indicating the kind of the extent of movement which is desired is 12. Then say so A to B movement is 12, and then say A to C movement, A to C or C to A movement is 50. A to C or C to A movement is 50. Likewise, A to D or D to A movement is like say 40. So, these are like say A to B are the adjacent work centers, and A to C and A to D are like C and D with respect to A are the non-adjacent work centers, and this L is indicating the kind of the movement which is desired. Then if we consider B to A, B and A, this is what we have already seen. Then B to C movement, B to C movement, B to C movement, these are the adjacent centers and the frequency of the movement is say 30, and B to D movement or D to B movement, either way it is B to D or D to B, it is 60. That is so very highest movement here it is showing the B to D movement. These are also non-adjacent work centers, these are not located next to each other. Then the C to D movement or D to C movement, these are also the adjacent, these are the adjacent work centers, and the load or the frequency of the movement is 18. If we assume that the distance between the center to center distance between these work centers is of the same, like say A to B distance is of the 1 unit, likewise B to C is another 1 unit, C to D is again another 1 unit, right. So, in that case A to B distance is, so here what we will write, distance A to B is 1 unit, then A to C is will be 2 units like this. So, here 2 unit distance, A to D will be 3 unit distance, B to C will be 1 unit distance, and then B to D 2 unit distances and C to D is 1 unit distance. And if we determine the, like say if the cost distance cost on account of the distance to be travelled per unit length is say C or K, we can write anything. So, say if we write K is the cost in rupees, K per unit distance, then that we can simply multiply K here with all these parameters. It can be 1 or anything else also we can assume suitably. So, the value which will come out like load into distance into the cost per unit distance K. So, here it will be 12 K first, then 100 K, 12 into 1 into K, 12 K, 50 into 2, that is 100 K, then 40 into 3 into K, 120 K, then 30 into 1, 30 K, then 60 into 2 into K, 120 K, and 18 into 1, 18 K. So, our sum of all these load into distance into the cost per unit length will be coming out say 400 K. So, in this setup, when the facilities are arranged A, B, C, D in sequence, the kind of the cost that will be occurring in this layout on account of the all types of the movement, that is coming say 400 K. If this arrangement is shifted little bit and the shift is made differently, like the work centers which are having the high load into the distance values, they can be brought close to each other, or those work centers which are causing higher cost, they can be brought close to each other. So, if we see this data, the center A and D, the cost is 120 K and the center 120 D, sorry, center B and D, these are also non-adjacent. Center B and D and A and D are the non-adjacent centers and causing very high cost 120 K each in both the cases. So, now efforts can be made, we will be identifying those centers which are causing higher cost first, and the efforts are made to bring them closer, so that the cost on account of the movement can be reduced. Next, after this the non-adjacent center A and C are also causing the high cost like 100 K. So, now first of all we will be bringing these centers which are causing the higher cost, and they will be brought close to each other by making them adjacent work centers. So, like say if we propose in the modified form, if the layout is redesigned in such a way, like first of all we have the B work facilities, then we have the D work facilities. So, that B and D which were causing the 120 K the cost on account of the movement has been brought close to each other, and then D and A were also not adjacent centers and causing the high cost of 120. So, like say it has been brought next to the D, and thereafter we will have the C work center. So, the centers which were causing the higher cost like A and C were causing the high cost of 100. So, they have been brought next to each other. D and A were causing the high cost of 120. So, they have been brought next to each other, likewise B and D. So, now the kind of the movement that we have between, now the movements will the extent of the distances to be travelled, load will remain same, but the distances to be travelled will get modified. Like say A and B, the load is how much now A and B, the kind of movement which is needed for A and B, the distance to be travelled between A and B is of the 2 units, or we can maybe we can yeah, let us say. So, here A and B, AC, AD, These are the kind of movements which exist: BC, BD and CD. These are the different movements. So, in the revised setup, AB movement is of the 2 units distance. The load that exists of the 12 load is 12, AC 50, AD 40, BC 30, BD 60 and CD 18 movement. Then the kind of distances now, because of the revision of the layout, distances to be travelled will get modified, like AB distance now has changed from 1 to 2 and AC distance has reduced from 2 to 1. AD distance now from 3 to it has been reduced to 1. BC has been increased to from 1 to 3 and A to BD distance between B and D has been reduced from 2 to 1 and CD distance between the C and D work centers has been increased from 1 to 2. So, 1 to 2, D to A to D to A or A to D is 1, like this. Now, if the cost per unit distance is same K in all the cases, then product of all these 3, load into the distance into the cost, that will be giving us the different quantity. So, 12 into 2 into K, 24 K, 50 into 1 into K, 50 K, 40 into 1 into K, that is 40 K, 30 into 3, 90 K, 60 into 1, 60 K and then 12 into 2, then 36 K. So, sum of all these, load into distance into K, for this will be coming out like say 300 K. So, if we see this, sum of all this will be 300 K. So, there is a reduction of the like say 100 K minus 300 K divided by 400 K. So, this will be causing the reduction in the cost by 25%. So, significant improvement will be there with the revision of the layout. Here the consideration of the frequency of the movement, the kind of the distance to be travelled and the cost that we have to pay for per unit distance to be travelled, consideration of all these 3 factors in development of the process layout will in general help us in reducing the cost required on account of the cost to be incurred on account of the movement between the different work centers. So, related with this only I will give the another example, like about these methods we have already talked, like flow matrix, flow cost model. So, just now I have talked about the flow cost model and the proximity chart. About this I have already talked. Let us take another example related with this. Like say this is the area where area 1 where the material is received and it is dispatched or the shipped from here, and the other areas like 2, 3, 4, 5, 6 through 7, 8, this is the packing area, 10, 11, 12, 13, 14, 15, 16, all these are the stores or the stacking locations or the store locations. So, what is done, normally material is received and it is stacked at these stores and then it is brought down and brought for shipping. It is taken from these stores, brought to the packing area. Here they are packed and then transported to the area 1 for shipping. So, it goes in very simple way. I will explain here the kind of movement which exists, like the material is received, then it is stacked at different stores. Whenever the order is received, material is taken out from these stores and then brought to the packing area. From packing area, material is packed and then it is brought to the again section area 1 where from it is shipped. So, this is the kind of movement. Material is received, then it is stored, then it is brought to the packing area, from packing area brought to the area 1, and then it is shipped. So, this is the kind of the existing setup, which in this existing setup, say inter center distance is like equal to the 1 unit. So, 1 to 2 to 3 distance is 1 unit, 2 to 4 distance is 2 units, 2 to 5 distance is 3 units, like this. But what kind of movement that we are having? Like we are from the stores, the material is brought to the packing area 9. So, if it is brought from the store 6 to the 9, then the distance to be travelled is 2 units. If it is brought from the store number 5, then distance to be travelled is 1 unit. And when the material packed at the packing area 9 and brought to the store 1, the distance to be travelled is 3 units. So, like this, the distance to be travelled are counted. So, now here it is just showing the current layout. Now, if we see the kind of the movement which is needed between these centers and the packing area. So, what we consider here, like the adjacent work centers load is considered first and non-adjacent work centers load is considered later. So, what are the adjacent centers? Like about the packing area 9, adjacent center is this 4, 9, 5, 15, 4, 13, 8 and 3. So, these are like say what is the movement from 9 to 3, 4 to 9, 5 to 9, 8 to 9, 10 to 9. So, all these 3, 4, 5, 10, 15, 14, 13 and 8, these are the adjacent areas. The distance to be travelled here will be minimum. So, what we do, the distance to be travelled, say in all these cases these are the adjacent centers. So, we will consider that distance is of 1 unit only. Now, we will see what is the kind of the load which is being transported from the different stores 3 to 4, 5, 8, 13, 14, 15 and 10 to area 9, that is shown here 8, like 9, 3 to 9 is the 80 load, 4 to 9 320 load, 5 to 9 140 load, 8 to 9 330 load. Likewise, the different loads which is generally observed, the kind of movement which exists between these centers and the between these stores and the packing area is here. So, now the load into the distance is multiplied, what we get, load into the distance, that all these are adjacent centers. So, they are multiplied by the 1 unit distance. So, what will be having this value, and sum of this will be giving us the load into distance only. If we multiplied with some cost k on account of the distance to be travelled per unit area, then it will be giving us like so, the L into D into the k cost per unit area, which is constant. So, for the load the cost, or you can say the load into distance into the cost for adjacent centers in this situation is coming out to be 1700 K. Now, if we consider the non-adjacent centers which are located far apart, like say non-adjacent center is 16, 11, 16, 6, 11, 16, then 2, 7 and 12. So, now again we will be considering the kind of movement which exists from 2 to 9, 6 to 9, 7 to 9, 11 to 9, 12 to 9, 16, 9 and 9 to 1. 9 to 1 movement is also a non-adjacent work centers movement. And so, here in all these cases, like say the distance to be travelled in case of the 9 to 1 is 3, while in all other cases the distance to be travelled is 2 only, like 9 to 16, 9 to 11, 9 to 6, 9 to 11, 9 to 16, or 9 to 2, 9 to 7 or 9 to 12. In all these cases distance to be travelled is 2 only. The 3 unit distance is to be travelled for all movements from 9 to 1. So, these are the distances to be travelled uh, from the different stores to the packing area, and then from one packing area and packing area 9 to the shipping area, and this is showing the kind of the load which exists. So, whatever is packed has to be transported to the shipping area 1, that is why this value is extremely high, and the distance to be travelled is also maximum for this case. So, if we consider the load into distance rating for this situation, so 500 into 2, that is the load into the distance. So, it is 1000, then 1300, 300, 320, 200, 280, 1000 and 7500. So, the load into the distance, sum of this for all non-adjacent centers is coming 10,600, and if we sum up the cost occurring on account of the adjacent centers and non-adjacent centers, in that case it will be like 10,600 plus 1700, which was for the adjacent centers, and this was for non-adjacent centers. So, it is coming 12,300 K. So, this is the kind of the total cost in the current scenario of the layout. If we see, if the considering the total cost which is coming maximum for non-adjacent centers 9-1, this is one thing. 9-1 movement, 9 to 1 area movement is maximum. So, we will be thinking of to reduce this value. Thereafter, the other movements like the 2 to 9 and the 16 to 9 movements are also high. So, we will be making efforts to reduce the to move or relocate the centers which are non-adjacent and having the high load in terms of the frequency of the movement. So, in the revised layout, since the 16, if we see here, since the movement between 9 and 1, this is the highest of the value 2500 unit into 3, causing this load into distance is 7500 value. On the other hand, the another highest is the 16 to 9 movement, that is of the 500 to 1000, and on the another highest load into the distance centers is like 2 to 9, 2 to 9. So, 500 to 2, causing the 1000. So, what we will be thinking of, first of all, to reduce these load into the distance factors by relocating the centers in such a way that the total load into distance into the cost factor is reduced. So, shifting of the centers is highly suggested. So, here in the revised layout, what has been done, like the center 9, the packing area now has been brought close to the shipping area 1, and so now the center and the now center 16, which was located at the corner here, now has been brought close to the packing area 9, and in this way shifting of the packing area 9 towards the shipping area has reduced the distance between the store 9 and the packing area also. So, in this way the packing area and the store 16 and 9 and the shipping area, which were causing the very high cost on account of the load into the distance into the cost factors, all that has been reduced. So, it is expected that it will be reducing the total cost also. To see the effectiveness of the revised layout, again we have to determine the load into the distance into the cost consideration in the revised situation. So, here this is the revised layout only. So, the 2, 9 and 16 and works one shipping area which were causing the high cost. So, we will be considering the adjacent centers load, load into distance into the cost factors, and then non adjacent centers. So, non adjacent centers are like 9,4, 9,2, 9,7, 9,13, 9,16, 9,15, 9,8 and 9,6. Whatever movement is needed from these stores to the packing area 9, they will be the adjacent centers. So, accordingly, since the load is same, only the distances have been reduced. So, accordingly, the load into the distance ratings will get modified. So, in the revised format, the load into distance rating, sum of the load into the distance factor for the adjacent centers is coming out to be 2440. Now, we consider non adjacent centers like 9 to 1, 9 to 5, 9 to 10, 9 to 12, 9 to 3, 9 to 11, 9 to 14. So, 9, 3, 5, 10, 11, 12, 14. Again, we will be considering the load into the distance factor rating for the non adjacent centers, and what we will be getting, sum of all these load into distance factors for the revised layout is, say, for non adjacent work centers is like, say, 6,900. So, sum of the total load distance ratings for adjacent centers is 2,440 and for non adjacent centers 6,900. So, sum will be like 9,440. So, here now what we will see, here is that if you multiply with some common cost factors, we can compare the costing easily. So, the load into distance rating which was there earlier significantly high of the 12,300, now it has been in after the revising the layout, it has been reduced to the 9,440. So, if you want to see the effectiveness, the percentage reduction in the costing which will be taking place, so that we can see like 12,000, how much it was, 12,300 minus 9,440 divided by 12,300. So, this will giving us the percentage of the saving that will be occurring on account of the movement which is needed between the different work centers. So, now I will summarize this presentation. In this presentation, basically I have talked about the procedure for designing the process layout considering the frequency of the movement, distance to be travelled and the cost which will be occurring on account of the per unit distance to be travelled. Thank you for your attention.